My name is Kelly Pathel, Technical Manager for Inveno Engineering LLC. And today I want to review case study number 28, root cause analysis, lost production temperatures in the process. This root cause analysis was done on a rotating dryer. Process dryer had loss of temperatures during operation, which was causing issues with production, product rejects, and slowing the machine systems down. The dryer surface temperatures are inconsistent. They're not a steady temperature for the different process applications that are occurring through the system. Therefore, review for operation, installation, and safety compliance. One of the items that came to our attention immediately was there needs to be a pressure gauge at the inlet of this process here. There was a question exactly what pressure is after the control valves. The steam pressure is coming through isolation valve, strainer, and a control valve. Therefore, we really need to know what pressure is coming into this process unit right here. The other thing is the ball valves that are installed here on the system do not meet the code compliance. They're not rated for the pressure and temperature of the operating system. Therefore, they need to be changed. The next item we looked at was the review of the steam hoses. The steam hoses have reduced connections here. And then one of the things that reduced connections is that restricts flow of steam going into the dryer, rotating dryer, and condensate coming out of the dryer. We don't, if the connections are 1.5 inches, we want 1.5 inch hoses, unrestricted flow. The other thing that happens is that the dryer hoses do not meet B31.1 code requirements, therefore they're not in code compliance. One other item here is the hose should come down a little bit further, more vertical, to assist in the siphoning action of removing the condensate from the rotating dryer. Next is we looked at the condensate drainage side, and this is the condensate coming down here. There is a strainer here, but the strainer did not have a blow-off valve on the strainer. We had to shut the system down and take a look at them. The strainer was probably around 35% plugged, which was restricting flow coming to the steam trap. The steam trap located here is the correct steam trap. It's a floating thermostatic design steam trap. However, on investigation, we found the steam trap does not have the correct orifice. The orifice in there was a small orifice, which was again reducing the capacity of the steam trap. The other thing on rotating dryers that we'd like to do is come off and bypass around the steam trap with a needle valve and come back into the condensate return system so we get some blow through steam, which assists in the evacuation of a rotating dryer. The other thing on the system is that during operation there is steam leaks from the threaded connections, and we want to eliminate threaded connections as much as possible, or totally. The other item was there is a check valve in the system, again restricting the flow. In this particular system there is no need for a check valve because backflow cannot occur. And the last item is putting a pressure gauge here so we know the condensate return line pressure, because the steam trap is a delta P device, P1 at the inlet and P2 here at the outlet. So pressure gauges always tell us the pressures that are occurring. I always say what happens tomorrow, short term, replace the steam hoses with correctly sized and code compliant. Correct the steam trap orifice, and we'll send technical data sheets along with this email on this presentation. Isolation valves, of course, need to be replaced because they're not in code compliance, but this is a safety issue. Install pressure gauges so we know the steam pressures and the condensate line pressures, and install ball valve on the strainer so we get PM blowdowns of the strainer, and remove the check valve. It's a restriction in the piping. There's no need for the ball valve. check valve. The install ball valves for isolation, always highly recommend. Design standardize on a proper steam trap station. This happens to be a steam trap station using tubing, tube connectors, ball valves for isolation. Back here is the blow-off valve for the strainer that's built internally, and the steam trap located. A very small, compact package, and eliminates threaded connections. Just one of many steam trap station designs. Here is our approach. Short term, we do steam balancing, steam reliability, and steam engineering training. Long term, we do process changes, lowering steam costs, increasing reliability. If you have any questions regarding this correction roadmap, you can contact us at any of these emails, and we'd be more than happy to have a conference call and discuss all our findings. Thank you for your time. Have a great day.